an artificial orbit that will shield our planet from solar radiation. In trying to address this problem of climate change, we closely as follows. A particle orbiting the sun can shield Earth by absorbing or scattering radiation. A shield's overall effectiveness depends on its ability to sustain an orbit that casts shadow to the Earth. The distance between the L1 and that point, that's the point where the L1 actually is the point where the sun's gravitational force and the Earth's gravitational force are at equilibrium. So there will be no effect, no net effect on our orbit. It will not get that our orbit will not move, our particles will not move away either to the Earth's surface or be launched away to the sun. So that's the point we call the L1 Lagrange point. The distance between the Earth and that point is approximately what we call the Hill radius. It's given by SME. The other equation where SME is the centimeter axis of the Earth's orbit around the sun, and M in the numerator and the numerator and the denominator are just the masses of the sun and the Earth respectively. The amount of radiation absorbed or scattered by a particle is gauged by the cross section as given in that equation, where QEXT is the efficiency factor, while R P is the radius of the particle. Light scattered by reflection and refraction is characterized by a phase function phi theta, giving the amount of incident light that scatters at an angle theta relative to the direction of travel of the incident. The anisotropic parameter is a very important parameter, which is given by that equation, which is explained by that integration of a solid angle in either indicates an average, whether light is on average scattered or forward scattered or neither. It is isotropic scattering. Scattering outcomes strongly depend on the size of particles. Particles with more than 1 micrometer, bigger than the typical wavelength of solar radiation, persistence time defined as the time that the Earth is free shed before swept away by solar radiation, by solar wind and index of radiation pressure is given by that equation. These two are very important in shaping the Earth's surface. As that graph shows, the persistence time versus the force of radiation, the time of force. The third one, a combination of the forces. Now from these graphs, they observe that grains are not sufficient scatterers of sunlight when they are around the 1 micrometer size. Nice grains typically have high beta, possibly to the point where radiation pressure makes these grains unbound to the sun. Materials with significant fault scattering is less susceptible to radiation pressure than backscatterers. More massive grains, by virtue of increased density and size, have smaller beta than less massive ones. Availability and location of lunar dust, presumably mined from the moon, or lunar surface, that is material, might be best choice for the urban location. Just completing.
Thank you. Thank you for your presentation.
Just the last slide.
We insisted that we were going to give you 10 minutes. Please, I'm sorry. We will interact with your presentation when we ask you questions. The next presentation, we have finished with the climate change aspects. We go now to agriculture and food security.
Good afternoon, ladies and gentlemen. I'm Moses Njoka. I'll be writing on chia production, which is a review of the status of the crop in Kenya. Professor Peter Masinde and Dr. Sinde Mugo, also the authors of that paper. Chia is a small oval seed, which is a superfood. Some will call it, some others will call it as a golden of Aztec. Others will also call it the beauty, the sleeping beauty. And so with all that names, it means that chia has numerous benefits in terms of the health benefits. Remember this, in this era we are now, people are trying to move from those foods which we think they cause obesity and such kind of foods. For chia, we are looking at a seed which can reduce obesity, which can reduce things to do with cardiovascular issues of the body. And so we would like to move more to these foods and leave the foods which are bringing health problems to our life. Chia has grown significantly in 2014 when it was introduced in Kenya through the Ugandan border. It has grown since there, and it has grown to other regions like Rift Valley, Central Kenya, and other places like Meru. Getao et al. 2019 said that in Nyeri County, only 18% of farmers knew about the chia seed. Like many of you here probably don't know about the chia seed. So 18% probably is you, and then but 82% were 88% were ready to or willing to produce chia in their farms. The problem with the production of chia is that there is limited knowledge in terms of the economic knowledge, water management, pest management, harvesting, also in terms of also the limited access to quality seeds, the varieties. From the seeds, the seeds were introduced in Kenya, nobody has gone further to introduce new varieties, as you can see in the next slide. So presently, we have no locally developed seeds for chia production in Kenya. Some of the seeds that you can see there is black, there is a zonoti, there is a white, there is a spotted, there is a gulakak. In Kenya, we have only the spotted chia variety, which is only found in our region. Some of the varieties outside our region include the G8, we have the golden chia, we have the Salva 66. Uganda has beaten us in chia production, as you can see. Uganda has produced the Uga variety. In Kenya, we don't have those kind of things. So we need researchers to look at these type of varieties, new varieties which can be able to adapt to our climate. And with that, we can have more yields and more production. In Kenya, the average yield is is affected by various factors in terms of the crop management. On average, chia farmers in Kenya produce 500 kgs to 800 kgs. But a research was done here in Meru, and under these conditions, we were able to produce about 2.2 million tons, 2.2 tons per hectare of seed. According to a study by Berry et al., he found that fertilizing chia plants with an NPK of 90, 60, 75 produced a higher seed yield as compared when you fertilize the chia plants with 30 by 20 by 25. However, contradictory statement by Bochicho, where he found that there was no response of chia to any fertilizer or nitrogen. However, we did it here in Kenya and in Meru. We found that there was some influence. And when we subjected our chia seeds or chia plants to nitrogen, there was higher yields. For the other elements, we need to check for phosphorus, for phosphatic fertilizers, for the other type of elements for our fertilizers. We need to check whether there is any significant influence. And with this table, we can see that under a fertilizer rate of 120, there is higher yields, 3.82 tons. When we come to spacing, a closer spacing also resulted to a higher yield of 3.61. So we can produce our chia seeds or our chia and a fertilizer rate of 120 and also a spacing of 15 by 30. But we need researchers who can go beyond this. We need researchers who can go beyond our spacing and beyond our fertilizer levels. In terms of water management, chia can be irrigated or rain-fed. Drought is one of the biotic factors also in our ASAS area. Chia has been reported to be drought tolerant or resistant. However, when we did this in our area in Meru, we found that drought affected chia in a big way. With this linear regression, we found that chia plants were subjected to 100% field capacity. There was higher growth in terms of the leaf number, in terms of the stem diameter, in terms of the stem height. And this indicated that when we decrease the amount of water, the growth decreases to a certain point. These are some of the plants which have been affected by water with drought. You can see wilting and dying off. So we cannot say really that chia is a drought resistant. We can see this in our field. With this also, with drought, it will lead to insect pests and diseases. Chia has been characterized to produce insect pests. However, we have found that some insect pests which are commonly found in our chia plants are caterpillars, foliage, beetles, colored bugs, and whiteflies. Can we really say that chia can repel insect pests? Probably in those regions, but in our region we have found also that there is also no documentation. There is no documentation of failure of crops due to insect pests. Also, there have been 3 recognized diseases or viruses, which is tomato yellow spot virus, cedar mosaic virus, and also cowpea milk mottle virus. We need researchers to look at these viruses because we have found them in our fields. Some of these pests we have is these pests which we are unable to recognize which is it. The second one is where caterpillars also eating. We have the mealybugs. We need researchers to look at this type of pest. These market opportunities with chia. A kg of chia goes with 1,500 to 2,000. So if you have one kg of chia, you are sure that you go home with some money, very good money. So you have 1 hectare, you expect 2.3 tons of chia, and that one is going to a million per ton. This is a success story. We visited a farmer who also came to a farmer's day, and we were able to help him to start doing sustainable agriculture. And we enabled him to produce chia in terms of food management. And these are the products of chia after that. We can see that he was able to produce some porridge, some milk, which has gluten of chia. we also produce capsulated oil from chia. And this is a success story for chia farmers. In conclusion, is that we want that the government and the other stakeholders and research institutions to come in front and help chia to grow. Also, recommendations will also want to strengthen the access to quality seeds in terms of varieties and also enhance technical knowledge to our farmers. We need our farmers to know about chia. We need them to understand that chia is the superfood. Thank you.
Thank you very much, Dr. You are actually appeared to 10 minutes. We have the next presenter. Yes, sir. Daniel Mwandu.
Cereals such as millet, maize, cassava, and sorghum were sourced randomly from Kakamega municipal market, and they were cleaned by removing impurities, then weighed at our local mill here in Chibu, and stored in clean plastic containers at room temperature before use. KCC Mala was bought from a local supermarket in Meru Town, Kenya. Steep porridge was prepared by a traditional method whereby the ratio of flour to water was 3:5, and the flour formulations used was based on a Kenyan survey by Wanjala et al., whereby, for instance, if it was maize and millet, we prepared them in the ratio of 4:1. Proximate analysis was determined using AOSC methods, whereby the moisture content was determined by the open dry method, fat by source-made method, carbohydrate by difference, fiber by the Stockman method, and protein by the Jeddah method. Ethical approval was sought from the UEC, and the GI was determined using standard procedures as recommended by BIMS, in which health participants with the correct BMI, blood pressure, and blood glucose were used in this study. The results: 6 organic types were prepared, and this is a table indicating the approximate composition, which is the moisture content, fat, protein, ash, fiber, carbohydrate content, and energy provided by these organics. The superscripts that we see there are significant differences among these various organic types, and it was determined using GenStat via the Duncan test. The moisture content of maize millet was the highest, whereas that of cassava sorghum was the lowest. And we can see that they are very significantly different. And we can see also that as much as maize millet only had a high moisture content, the significant difference with cassava was there was no significant difference, and this can be explained by the fact that cassava has a very good ability to gain moisture because of its fine texture. On fat, maize millet had the highest fat content, with cassava showing the lowest fat content, and they were significantly different. And this is because cassava is known to be deficient of fat, and the maize millet would be explained by the fact that maize has a very large germ that contains this fat, and also the millet has various layers, that is the alluvial layer and the pericarp layer, which have been shown to contain fat and may have contributed to this high fat that you can see. Cassava barley had the lowest protein content, with its composites showing an increase. Sorghum has been shown to have high protein content, and this would explain why the various cassava composites had an increased protein content. Additionally, the cassava has also been shown to be deficient of this protein. Cassava millet ugali recorded the highest ash and fiber content, and this is because millet is rich in minerals, and the pericarp itself, having 5 layers, contributes to the high fiber. Cassava stiff porridge had the highest carbohydrate content, whereas that of maize sorghum had the lowest, and this is because cassava is majorly consists of carbohydrates. Maize millet ugali had the highest energy values, and cassava had the lowest, and this can be explained by the fact that when we are calculating energy, we use fat, protein, the fiber, and the carbohydrates, the kilocalories provided, and you can see that in maize millet had a high fat and protein content, and this would have contributed to the high energy levels. 15 participants signed an informed consent, of which only 10 of them were healthy, had a healthy BMI, blood pressure, fasting blood glucose, and the portion sizes, as indicated in the table below, were supposed to contain 50 grams available carbohydrates. This is a figure of the blood sugar response after consumption of glucose, which was the reference food, and the various ugali types that I have mentioned. And we can see that the the rise after consumption of blood of glucose by participants was very sharp, and it was the highest, whereas consumption of stew porridges recorded a very steady response in terms of blood sugar responses. And this could be explained by the fact that glucose is rapidly digested, and this is why the blood sugar had a very sharp rise. The glycemic index of these stew porridges ranged from low to medium, with maize sorghum having a GI of 45, cassava millet 45, cassava sorghum 46, maize millet 47, and cassava sorghum millet 57. The high fiber present in cassava millet ugali would explain the low GI. This is because fiber delays digestion because of its viscous nature. The high fat content in maize millet ugali may attribute to the low GI that you can see here, and this is because fat delays digestion. All composite ugali were rich in either or both protein and fat, and this would have contributed to the low glycemic indexes that were.
Thank you. Thank you very much for your presentation. We will have our online presentation, and Daisy, I think, is presenting from Japan. Daisy is a student in biological sciences, I think.
Yes. Oh, okay. Hi, everybody. My name is.
Sorry to interrupt you. You say you have 10 minutes. Please, you really have to do a quick summary.
Okay. Okay. So I'm going to share my screen and my presentation. Okay, I hope everybody can see my screen. Okay, so I'm Daisy Prana from the School of Molecular Biology and Molecular Biology. I'm going to present a study on chloroplast movement in all strawberries, an ongoing study. And my supervisors are Dr. Cynthia Mombo from Yale University and Dr. Yutaka Kodama from Japan Autonomous University, where I'm right now. Okay, so straight to my research. So plants employ various tactics to adjust to changes in light levels in the environment, because just plants like animals don't have the ability to move around, and so they have developed different techniques in order to adapt to the environment. So one of these techniques is chloroplast movement, which is also known as photorelocation, as it is dependent on light, and is crucial to protect against excessive light, that is photo damage, in a response known as an avoidance response. And to optimize photosynthesis in low light conditions, a process known as an accumulation response, which helps these plants to maximize the available light in order to maximize photosynthesis. So we can see a diagram there. So this is a diagram of Ethaliana, that is So this is a picture showing a diagram showing accumulation response, as you can see in the first image here. So this is an accumulation response where the chloroplasts are accumulating towards the source of light. And in another one, you can see in the second one, you can see avoidance response, where the chloroplasts are showing an avoidance response and declining to the periclinal cell walls of cell walls in order to avoid photo damage. So this has been done in the different plants so far. Radiated with different intensities of blue in a LED incubator for 2 hours. And so from that, we got the results that, so treatment was a strong blue light, that is 200 photons, and under 22 degrees Celsius for 2 hours. So the blue and red channels were extracted from an RBG image, and a clear white band is seen, which confirms that chloroplast of Vesca showed an avoidance response under a strong blue light. And so in this diagram, you can see the images there. So the arrows, because it is a little bit dark, so the arrows do show the areas that were radiated, and therefore they show the region of the white band assay. So the white band assay shows an avoidance response where the chloroplast moved away from the region that was irradiated, hence creating a paler complexity compared to the other regions that were hidden from the light treatment. So for the red light, however, there was no change. And therefore we concluded that red light does not induce an avoidance response in Vesca under treatment of strong red light for 22 degrees Celsius and 2 hours, and those were the results. There's no change, there's no white bar. So from this, we've concluded that because the results in the blue light, the strong blue light was a little bit weak than expected, we have to construct a way or to define a quantification technique that we will use to quantify these results and promote or support the results that we achieved. So in acknowledgement, I acknowledge Meru University of Science and Technology, my university, where I'm based at, and Autonomy University of Japan, where I am currently, under a scholarship program, an exchange program under the program for developing human resource to contribute to SDGs by emerging African potential and Japanese scientific technology. That is a partnership between Autonomy University and Meru University of Science and Technology. So thank you.
Thank you very much, Daisy, for staying late to talk to us. We are going to give you, because we want to release you to go, and I think probably to sleep, is we'll ask 2-3 questions to Daisy so that we can let her go. Anyone? Yes?
Not really. The person who is talking, I can barely make out of their thing.
Daisy, we are saying we're going to ask you maybe 2-3 questions, and then we'll let you go.
Oh, okay.
So I will request that you come forward. Please come forward wherever you want to ask, because she will be using the computer mic.
Okay.
Come forward, please. Then anyone else who is interested in asking Daisy a question, please come forward.
Yeah, okay.
Yes, Kiprono.
Yes.
My question goes through your classification of the light wavelengths. You have 3 categories: the weak, strong, and another classification. So what I'm asking is, are these wavelengths determined? That is number 1, and I think that's important because in looking at your analysis, you are dealing with the RGB planes of an image. So how do you set these wavelengths, their magnitudes, and use them in your analysis of the RGB images? Why do you call them weak, strong? What parameter are you using to classify them?
Okay. We have an equipment where we use to test the different intensities of light, and currently the plants that I'm using to do my research are under like an incubator or a cultivating room, and the normal light intensity that the plants are being exposed to is 50 photons, which is averagely the normal light outside. So once we've measured that the normal growing light intensity is 50, then when we reduce that to around 10 or 20, that is classified as weak light, which is supposed to induce and avoid an accumulation response. And when you magnify that, double it to, let's say, 100 or 200 or further than that, anything above 100 photonewtons, as we've seen from previously done work, is considered a strong blue light. And so we did 100 photons before. We tested 100 photons, and it took a while for the test to be seen. In that, once you've tested, we scan the image in order to analyze it with an image analysis software, and it wouldn't be seen, because when you expose our plants to the treatment light, what happens is that the plant absorbs. It absorbs the different wavelengths of light, and so what we finally realized after testing is that 200 is okay. 200 is okay to induce an avoidance response in our strawberries. That is 200 photons.
Thank you, Daisy.
Thank you. Daisy, one thing, the blue light was of shorter wavelength than the red light, number 1. Number 2, we've seen an avoidance in the red light. Is that the reason why?
Yes.
Is that the reason why commercial farmers, mainly in running production, are using red light for production, especially at night?
That is a general thing. But different plants react to different kinds of lights. So we have different plants that react to red light and blue light, while we have others that react only to blue light. So as seen in so many papers that I've read and so many things that we've used to analyze and all these, that Italiana that you've seen in the image, in the first image, it reacts to both blue and red light. But in the wild strawberry, it does not react to the red light. It only reacts to the blue light, meaning it has the proteins. So the proteins that are contained in that are controlling the light, the accumulation and the avoidance response, only responds to the blue light, not the red light. And so I think all the other plants to have that fact that they either react to both red and blue, or just blue light, or just red light.
Thank you, Daisy. Anyone with a burning one? Thank you very much, and we appreciate your staying late to talk to us. Have a good night, and all the best as you study.
Thank you.
Who is Professor Remy? Are you ready? We are done with 3. Are we done 3? Oh, yeah, sure. That is. Sorry.
It is ready.
Yes, please. Okay. Then we now prepare your questions. We'll ask questions for the 7 who will have presented. No, I mean 6, because we are done with Daisy. Will bear with us. We are rushing you, but it's not that we don't appreciate your work. It's really because we want everyone who came to present their work. Please bear with us.
Okay, good afternoon. I'm presenting on behalf of Daniel Wawero, who is a PhD student under our supervision. The title of the presentation is Development and Characterization of Dovialis Cafra Fruit Yogurt. Basically, first of all, we understand what is Dovialis Cafra is what we call K-apple, the one we use for the fence. So those are the fruits that we are using to make, to add to the yogurt. They are originally from South Africa, and in Kenya it's mainly grows wildly, but as a recent gain used as establishing live fences. Its fruit is yet to gain any beneficial use in the country, despite it being edible. Therefore, there is a need to find ways to utilize the Dovialis cafra. Also, it's drought resistant. So that's the fruit. Across Kenya, food and nutrition insecurity remains a big thing, and there's both acute and chronic scenarios. So exploiting new and underutilized food and nutritional sources is one of the ways to combat that, and it contributes to reduction of the prevailing problem of food insecurity. So Dovialis cafra has that potential of being utilized. The objectives was to process bovine milk into Dovialis cafra fruit yogurt, and then to determine the physicochemical and microbiological and also sensorial properties of that fruit yogurt. So those are the methodologies. The fruits were sourced from Lanet, Nakuru. They were transported to Meru University. The yogurt was formulated and stored at 4 degrees for 3 weeks. And various physicochemical properties were determined, including pH, vitamin C, viscosity. And also sensory evaluation was done, and microbial analysis was also carried out. That's the physical appearance of the yogurt containing Dovialis cafra. It's yellowish because the fruit is also yellowish in color. D0 to D15 indicates the percentage of Doviaris cafra 100. So 0 is 0, 15 is 15%. Vitamin C content was observed to increase. I think you can see it's increasing from 0.02 to around 14.49, depending on the quantity of Doviaris cafra that's added to the yogurt. In terms of selected physicochemical characteristic of, in terms of pH, also decreased with the increasing amount of fruit. And Doviaris cafra or K-apple is basically a very acidic fruit, so you would expect that to reduce the pH. And also with the storage, from day 1 of storage of yogurt to day 21, the pH tended to decrease. In terms of viscosity, as we increased the amount of fruit in the yogurt, the viscosity decreased, but viscosity remained more stable in storage. Under normal circumstances, when you make yogurt during storage, the viscosity decreases, but in this case, that phenomena wasn't observed. In terms of color, based on sensory properties that were observed, is basically the yogurt that had 0% of the fruit was more perceived by panelists as the best. And as the amount of fruit increased in terms of color also, the perception decreased. Also in taste, texture as well, and also the overall acceptability. The one which didn't have any fruit was rated highest, the 0 fruit percent, compared to the one which had 15%. In terms of checking the microbial quality of yogurt over storage, we checked about molds and the yeasts. They were not detected in the product. So basically, the discussions, it's basically what I've gone through is Doviaris cafra yogurt can be considered as a novel, a healthy option from the ordinary yogurt. And because of one is high ascorbic acid. Ascorbic acid is known to be an antioxidant. It can boost the immune, and also as an anti-inflammatory properties and antihypertensive. The average scores in sensory indicate that Doviaris cafra yogurt had a greater potential for future improvement through optimizing that. And also viscosity was stable over the time. I think due to the acidity of Doviaris cafra, so microbial prevalence was not observed. So in summary, Doviaris cafra yogurt product has a great potential as a prospect of a novel product. So in conclusion, the yogurt was manufactured, the fruit yogurt was successfully manufactured with K-apple. It had higher vitamin C compared to the control yogurt. And it exhibited stable viscosity over the storage period. There are going to be further optimization of the product and also adoption of the fruit, not only as a live fence, but also for other purposes. So I think with that, I think Daniel and I put a photo there, which is not visible, but that's, thank you for your attention.
Thank you very much, Professor Remy, for the talk. Time is now ripe for. Can we have all the participants, all those who have presented, coming forward so that it becomes easy to ask questions, so that we can minimize time. Yes. 15. We have 15 minutes of questions. So please come forward so that whenever your question is asked, you can quickly answer. Yes. But I think it's okay if they stand, so that they can assist one another if they want. So, anyone who wants to start, then you can assist with the mic. I have one. I can start with Dr. Remy. Professor Remy, sorry. Prof, I don't know whether you are aware we have a species of Dovialis in Kenya. We have Dovialis kenyensis from the coast. So probably, I'm not saying what you've done is wrong, but I'm thinking probably you may also want to check out the new species that has been described from the coast province. It's actually called Dovialis kenyensis. But I appreciate the use of the rare used products as food. Mine was not a question, actually, it's more of a comment. Someone else?
Yes. My first question goes to presenter one, Edwin. If you followed Professor Remy's presentation, you saw how he placed his problem statement. What exactly are you solving? Number two, you mentioned the computation of areas in your work within the study locations. How are you using this parameter area in your analysis? Area is computed from GPS. That's what you mentioned. So how are you using it in your analysis?
So if I may start with the second question. Now, I said our studies were based, we went to what we call smallholder farms, between 1 and 5 acres. There are very many farms, but my study specifically, I went to 36 farms. 18 of them were what you call conventional farms. They are using conventional methods. And 18 of them were using what you call conservation farming methods. So the farming areas, we were just using the GPS because we went to the study very many people. But me, I was using the GPS, first of all, to get the size of the farm. So that later on, because I told you that this is just part of the studies, there's what we call extrapolation. The 236, for example, plants that I found in Kirinyaga, they do not represent all of Kirinyaga. So I need to get the size of the farms that I used to extrapolate and say, for example, now I can say with a high degree of confidence that we can say that in Kirinyaga County, in this number of farms, we can, for example, have this number of plants. You're getting it? So the GPS, the area of the farms, we are getting the GPS to get the area of the farms for extrapolative studies. Secondly, you asked about the main aim of the study. Now, the mother of this study, this is just part of the study. The objective of the study was to quantify what we call plant biodiversity and compare plant biodiversity in what we call conservation farms and conventional farms. And why are we doing these studies? We are saying that, if you can remember what I said at the beginning, is that we are hurting the environment in one way or another, trying to produce food for the people. If we can have better ways of production of food, so without hurting the environment, without hurting the species numbers. I said, like, from 1970 to now, we had around 69% of the species have been lost due to various things, among them agriculture. Now, if you can find better or advantages, for example, of conservation farms and document those advantages, then very many people can adopt this farming method and help improve the environment in a small way, in one way or another. I hope I've answered your question.
Thank you, Edwin. My co-chair is actually proposing a different way of questions. We ask all the questions first and then you guys respond at once. So is there another question for Edwin?
Edwin, what you have described should be the problem. The statistics about the figures is not the problem. You saying biodiversity to me is not the problem. Saying climate change, that is not the problem. How you come in, that brings the approach to the problem. Simple.
Thank you. I'm sure Edwin is noting down. Anyone else with the question for Edwin? I have one, Edwin. When you mean plant diversity in conservation versus conventional, are you not being obvious? Because, I mean, in conventional farming, you expect monocropping. So you don't expect diversity there other than what is planted. So you're comparing goats and sheep. I would have thought, probably, I'm just thinking, I would have thought it would have been better to use different types of conservation farming, because they do exist. Think about it. You can respond when time comes. Anyone else? Now let's go to presenter number 2, Muteti. Anyone with a question for Muteti? Yes. Muteti, please pick a piece of paper so that you note your questions.
My concern is just similar. Your problem statement does not correlate to your objectives. So what are the objectives meant for? You can refer to your work.
Anyone else, please? And when you're answering, we'll look at your problem statement and objectives. Yes. Modia, go and then.
Thank you. Mutati, also you said you selected counties, you used random sampling to select your counties. So that is one. So the issue is how did you randomly sample to come up with the 4 counties?
I have a comment or question from Muteti. If I got you right, it's a similar thing to what Mora is asking. You said you did purposive sampling to select counties, and then you did simple random sampling to select farms, right? So I wanted to know what influenced your choice of purposive sampling for the counties. What factors did you consider to go that way? And also tell me, how many samples did you eventually work with? How many farms did you eventually work with? And what formula, what did you use to determine the sample size? Thank you.
Anyone else with a question for Muteti?
Forgive me to come back to you, Muteti. Sampling has been mentioned. I have a list here I thought is for other presenters. It's for you. So what is the error margin of the pH meter that you used in your measurements, and how does that influence your output?
The next person is Kennedy.
Sorry, I remember something else. So in those 4 counties, what were the agroecological zone that you settled on? In every county where you did your work, what could have been on, what were the agroecological zones?
Again, as you answer those, tell us why you decided to look at soil microbial diversity and species diversity, and what does each one of them give different from the other. Then the question for Kennedy. Have you noticed?
Yes, to Ken Konga, you did not get the problem that you are solving. And number 2, you are giving us a very broad topic about dust as buffer in solar radiation studies. What in specific? Which field of solar radiation? I mean, what is your area of study within that broad topic? And I got confused and lost a lot because I thought we should see something that is based into an experiment and a result, but you seem to be doing review work. What kind of study are you doing? Is it review work, or what exactly are you presenting?
Does your formula take care of rain, hail, snow, and wind currents that are moving particles across the mountains and ridges?
Anyone else? From Kennedy, I got it was theoretical physics, right? It's a theoretical proposal. And you even propose, some people are talking about aerosols. I know there are people who have talked about, what was that chemicals there? I don't think they are aerosols, are they? I don't think so. CFCs? No, not CFC. I know some people have been proposing things, but I don't think they have been proposing to that altitude you're talking about. And how you intend, does your theory take into consideration how you'd even take dust there? Because I mean, if it's theoretical, even though it's theoretical, it has to be possible. Anyone else? Yes, there's someone up there who want to.
Mine is not a question, is a compliment and an appreciation for the lady who made a presentation on the types of flour.
Oh, that's Lorraine.
Lorraine.
Yes.
Lorraine, your presentation was very good, and I hope that you will get it out to the public, the consumers of those flours, because there are many of them, and the people just go to the markets, especially on Kirinyaga Road, and just say, put for me this, and this, but they don't know why they are asking for those kind of flours. Thank you.
You jumped the queue, but it's all right. So it's a compliment. What I got confused about is it that the hill radius you talked about, it doesn't have an absolute figure of the distance. Because I mean, I'm sure that's a known distance from the Earth to wherever you're proposing. So instead of giving us a formula, why don't you tell us this distance so that for us we can't visualize where hill radius is. I assume the figures I saw, Kennedy, again, were simulations. So in real essence, you're not sure how the particles will behave because there are so many factors probably you didn't feed in your models. What was your model like? Anyway, think about, tell us how your model was like so that we can see what parameters you actually found in your model. Next was whom? Joka? Questions for Joka?
Thank you, Moses, for your presentations. Just two very minor comments. I thought I heard you make a comment like, well, if you decrease water levels, that would lead to decrease in growth. And I was wondering, isn't that obvious? Is that really a research issue, or isn't that an obvious comment to make? Maybe you should tell us, it decreased growth by what levels? You know, give us something that is not obvious. And then you made a very good pitch for chair. It sounded like a wonder crop. And just reminded me sometime back when there was a very wonderful pitch for things called quail. They were supposed to be the magic bullet for so many problems. And farmers got them, and suddenly the whole idea collapsed. I'm wondering, are you overhyping, Chair? What are the facts? What are the facts? Thank you.
Oh, thank you. Thank you, Joka, for the good presentation. You cited some what farmers can accrue by growing chia in a hectare, like a ton, and it was a very lucrative figure. I'm wondering, do you have that market? If all the farmers, let's only say in Meru, produced a lot of chia, is there a market for it, or it's just theoretical for that accrue?
Joka, also, Sylvia et al. Reported that chia is drought resistant. You reported that it is not drought resistant. What was the difference between your work and Sylvia's work? Number two, please can you tell us the nutritional composition of chia before you tell us that it can prevent heart attack, obesity, and the rest?
Thank you very much. Before the quail, there was the desert rose with oil. And now we are hearing chia. But that is not where I'm going. Talk again, you talked about productivity and fertilizers. Remember, we are all talking climate change and we are trying to actually minimize fertilizer use. Maybe you want to look at what are other factors other than just fertilizers. Say, for example, microbial interactions. How would microbial interactions increase or decrease productivity? Things like mycorrhiza, they are known to increase productivity without necessarily adding fertilizer to crops. Anybody else? Okay, the next person is when it's you, it's Rolin. Questions for Rolin? They start and there's...
Lorraine, thank you for your presentation. Of course, it's a very important subject, and I want to appreciate that already you've been commended. But even if it was good, there are still some issues here and there. A small comment is this: your slides are a little congested. I mean, the data in the tables, it's a little hard to visualize. But now a question. You said the porridges you're making were targeted patients with type 2 diabetes. Why not type 1? Could you explain to me why?
Yes, Lorraine, let me confess I got confused in your final graph, the graph that you explained about the foodstuffs drawn in lines. So the horizontal axis had the label time, while the graphs inside speak something else. What you explained about the vertical axis was okay. What should be labeled for the horizontal axis? Is it what in the graph or something else? How does time come in and how does it relate to what is inside the four graphs? Label I'm not sure if I got you well, but I think there's an issue with that presentation, that graph. Can you clarify?
Anybody else who wants to go?
Already you said that the GI of most of our African food or flour is not known. It does not appear in the international table you spoke about. Well, it's very easy for you to graduate. Why just do all of them and publish? No one will question.
Thank you very much. Mine is, I'm going to be a layman here now because this field is something I'm not very good at all. But I've always wondered, why is diabetes an issue? Is it food? Is it lifestyle? Is it diet? Because it is prevalent a lot in African race. And I think there is it's not just about the food we are eating, it's what we are not eating, I think. That's me. I think there's something we are not eating. We are eating the wrong things. So the sugars can spike, but there should be something else to interact it. But probably you've come across something. I'm asking innocently because why is it that it is more prevalent in African race now, in the modern time? Even if you go to the US, for example, where there are a big number of African Americans, it is actually more prevalent in African American race than all the other races. And the food, the diet of African Americans is way narrower than any other race in the US. That is why I'm convinced it is not what we are eating that is causing. I don't know. I'm proposing. Maybe you can shed some light on that. Anyone else? Is someone up there?
Hi, Lorraine. Nice presentation. Maybe a thought, something I do myself. I wish next time you could include maybe research when you mix white maize and yellow maize. What does that mean for the nutritional part? Maybe in terms of making the stiff porridge more healthy. And also, I didn't get to see maybe a parameter in terms of taste of all those mixtures, because fundamentally food basically is taste. So no matter how healthy it is, what about the taste?
I think now we'll give the respondents time. Please come so that we can, we have Cindy here, the last person, and then we'll start hearing their responses.
Thank you, Chair. Mine is for Professor Remy. I think you forgot about him.
Oh!
He was the last presenter.
You're a professor.
So I just wanted to understand, I think probably I did not get it in your presentation when you meant the yogurt with zero fruit. Please explain that a little bit. And then the toxicity of the Dovialis cafra. Did you consider that, or it does not have a toxicity level? Thanks.
Mine is to, again, Prof. Just out of curiosity, if it succeeds to be very good yogurt, how would we, is there a way of multiplying these Kafra plants or cultivating, the Dovialis? And it's a very thorny plant, isn't it? How do you pick so many berries?
Also to Daniel Mwangi, not to Professor Remy, but to Daniel Mwangi. You said that the yogurt with zero fruit was liked the most. That the control sample is what the people liked. They didn't, all the ones that had the test material, if I may put it that way, were not preferred as much. What does that mean in terms of potential commercial application of that technology? And then, still related to that, would possibly have explaining to the panelists the possible benefits of having the Dovialis kapha in the yogurt? Would that have maybe have improved the acceptability? Thank you.
Thank you, Prof, for the presentation. So I once tasted the fruit and it was quite acidic, and I don't think I'd like it in my yogurt. So have you done anything on the taste of that fruit? Or I'm just curious about or whether it's how you select the fruit, or how have you done about the taste of that fruit in the yogurt? Thank you.
Okay, thank you very much. And like I said, there is Andovialis kenyensis. Probably it is less acidic. Probably that's, they may also want to test that one out. Now we can have Edwin finishing off his questions. He's the first one.
So I think the question that you
And
asked...
please be brief, because
Okay.
we want everyone to answer their questions.
Okay. The main part of the study is to quantify plant biodiversity. So, in the counties that we had the study, most of them, they were practicing the same type of conservative agriculture. The same principles were being applied in the farms that we are visiting, because they started conservation agriculture because they were prompted by an organization. So that organization usually paid employees what we call extension officers, and using the same principle. So comparing from the samples from the counties that I had, it would be just comparing the same. But the main aim was to quantify plant biodiversity. Yes. Yes. It's not that straightforward when you go to the field, because even those people who are practicing what we call conventional farms, when you look at the result, for example, of Laikipia County, you'll find that, for example, tree species in Laikipia, the what we call biodiversity, the reciprocal index is almost there, almost here and here, because of several reasons. But the full study, I think, is going to bring out everything clearly. Thank you.
Thank you. The question about the selection of counties, I used purposive sampling design because conservation farming, it is cultivated in Mount Kenya. For example, we used farms, conservation farms in Mount Kenya, and an international group called TIST. So the TIST group is the one which control the conservation farming in Kenya. So that's why it was purposive. Yes.
In other words, you are telling us the study sites are already decided. Prof, is it so? That the study sites for this larger group was already decided, so probably what they were doing, they were either subsampling from the larger, because I can see why Yanto asked why for.
Okay, maybe I may clarify that. These taste farmers, they are groups, they even go up to Kakamega, but we looked at Mount Kenya region. We looked on the leeward side, on the other side with less rainfall, so that I think Dr. Mori had asked about that. Yes. So we selected, it was purposeful sampling, but then we took both on the windward and the leeward side with different amounts of rainfall, and the conservation farms with quite different.
I asked that because a pattern was almost coming, that these guys are actually working on the similar. So Muteti then, probably what he is asking is valid.
So I think now the original document asked
Yes. They should, that is what they should be using in their presentations. Don't invent your own methods when the methods are already decided. Now you can go to the next. That one we have ascertained what there is. But when you're presenting, present with that in mind. Okay?
The other question is the formula I used to calculate the number of farms, the 40 farms. Yes, there is formula I used, but now I'm not, okay. How I calculated the number of farms. How I got 40 farms from the population.
Are they 40?
No.
Yes. You can go and find out because you really want to, when you say calculating 40 farms, from what? Okay? So you get what we are asking. Okay, now next. It was something about objectives. Remember, we were actually improving your work.
Yes.
We are not here to harass you.
Yeah. Why I decided to work on soil biodiversity and physiochemical property.
He said, if I remember very well, that your topic is not relating to the objectives. Is it so, sir? The problem statement is not marrying with the objectives. Yes. What was your problem statement? You talked about soil, microorganisms.
Yeah. And physiochemical properties.
Yes. But I asked about species richness and species diversity.
Yeah.
First of all, personally, I don't think calculation of species richness can actually be an objective. That is what you proposed as objective 1. That's a very simple, it's one formula. It's one formula, Muteti. You can't say that's an objective. But why are you deciding to calculate in diversity and richness?
Those are the species richness and species and diversity. Those are indicators of soil health. You can use them to measure if the soil is healthy.
Diversity of the richness.
The diversity of soil organisms and their richness and evenness. It's a measure, we can use them to measure soil health.
Okay, so what you do, you actually ensure that you tell us why you're doing certain tests. And probably you want to combine all that into one objective.
Okay.
That you are setting out to do. Okay, the next person was Kennedy, I think. Is it you? Right? Yeah.
Okay, I want to deal with these questions. Okay, first question was hill radius, that formula for hill radius. I think I forgot I used the astronomical units instead of the dimensions known. Yes, which was 0.0.
So what are the dimensions? What is
the dimensional in terms of kilometers? It's around 1.946 times 10 power 6 kilometers. Yeah, that's what I forgot to write. I used
you have not helped us. We want them to be told that 2 million kilometers. Something like that. So that we can visualize whether it is possible even to place just there.
All right. It's around 1,946 kilometers. 1,946,000 kilometers.
How far is the Space International spacecraft? 400 kilometers or 300 something? I'm trying to imagine practicability of putting dust there.
Okay. We launched them using rockets.
Yeah.
Of course, we've gone to the moon.
True.
Yes. Which is about
So it is possible.
3. Yes, it's possible. Yes.
I asked about parameters of your
The parameters
of your simulations of the survival of the dust in the environment.
Environment.
You must have had parameters to run a simulation.
Of course. The parameters we use, of course, the sample size of the dust, sizes. And now, how will they get hold of those skies? Yes. At that point, the Lagrange point actually is a point between the sun and the moon where there is the gravitational acceleration to the sun and the gravitational acceleration to the earth are at equilibrium. That means past that point, at that point the dust will orbit, the orbit which we are creating won't be affected by the gravitational forces. But and I explained about the radiation pressure and solar wind. Those are what we call the non-gravitational forces, which will affect which we have gated by introducing what we call the persistence time versus the...
But it's good to be very clear on your parameters, because if I was evaluating your paper, I would want to see those parameters. How did you parameterize your model? So that I can tell whether the model actually can stand, right? Was there another question? Have you finished?
Okay. No, the last one.
Yes.
You asked about effects of winds, the snows. I didn't get it about. Yes, they are non-gravitational forces. Yeah.
Yes. Who else is left? Arimi, I think you still have a few.
Have you addressed? Okay, thank you. And quite a number of questions. One was the zero yogurt. It's the conventional yogurt without any fruit. Toxicity, we didn't consider that. The various CAFRA, they are normally consumed, but scientifically we haven't checked the toxicity, but empirically we see people eating them. We haven't found any case so far. Ways of multiplying, I think actually currently it's used for the fence. If you allow it to overgrow, it starts to give the fruit. So there's a possibility of that. And I see those people with tree nurseries on road signs. They have a lot of these K apples for the fences. So if you want to multiply, it's quite easy. The other question was, the control was liked most. So where do we stop with science? I will be as blunt as I can get. With science, we can do anything to start with. Even if it's poisonous, we can stand it. But to come to practicability is because we tested the sensory with the conventional consumers. So consumers are what they are used to. Initially, there is always a resistance. So they perceived the ones with the fruits, the less accepted. But once you make the product, you ask whether we can explain the benefits. Thereafter, that can be magnified to increase the consumer acceptance. But also there's what we call market niche. You could have a specific niche that wants that kind of a product. I give an example of alcohol. Kuna watu wanasikia ikiwa chungu, and there are people who taste it sweet. So it depends. Another question was, the fruit is very acidic. Didn't do anything to improve the taste. As a consumer, definitely this is what consumers ask first. But as scientists, sometimes we want to push the envelope. It's not always, that's what I think even the introduction morning, you need to introduce new products, novel products in different tastes, in different colors, in different, all that. And also I heard the chairman asking, is it not what we eat, perhaps we need to eat this. Maybe this one is what will help whether we have a problem. I think so. The other one is we have a local Doviaris. Perhaps in the future work, we will venture into that. Thank you.
Thank you for the questions and the comments. The first question was on why type 2 diabetes and not type 1. This is because type 1 diabetes is genetic, and generally you cannot produce any insulin to control your blood glucose. Yeah, and on the second question about the figure, it was showing the blood glucose response against time. The horizontal axis was time, blood glucose. The blood glucose.
Yeah, actually, I think that's what I saw. So I thought the graph was okay. Yeah.
So basically, the graph is just trying to show you how your blood sugar responds after you've consumed a food within a period of 2 hours. Then, why is diabetes still an issue? It's still an issue because the prevalence is increasing year by year.
No, that is what I asked. I was saying maybe, and I'm not saying what, like, maybe we also need to concentrate on why is it prevalent? Why is the prevalence increasing? Or even another rule you are asking. Is it just food, or there could be something else? Maybe I can almost use this word.
Maybe. Yeah. Concerning tastes, most of the participants that were involved in this study were young, and they were able to consume this ugali. The only ugali that was not able to be consumed was the cassava ugali. And with that, I know it might have, some few problems in terms of reaching and being accepted into the market. Thank you.
And yellow maize versus white maize. That's what she asked.
Yeah, future work.
Thank you. I think chia is not like quail or such kind of things, because chia can be introduced to any meal. Talk about porridge, talk about water, talk about anything. You can introduce it. It is tasteless. It's odorless. We're talking about chia. Chia is the best. So with that also say that when you're talking about water management, drought resistant, a paper was talked about drought resistant, but I think because of the varieties that they had chosen, that's why they had said about drought resistant. But the variety we used here tended to not to resist drought. The next question about the market. When you're talking about the market, I'm saying that we can introduce it to either food because it's tasted and odorless. So I'm saying this, that our market, we cannot finish this market. This market will always emerge because this product has not been used. In Kenya, we're using it in yogurt, we're using it in porridge. So we cannot do away with this. Let us grow this crop and let us become rich.
What you have not said is that chia is a mint. Can we use the leaves as mint?
Yes, also we can eat on the leaf.
You see, you're not promoting your crop very well. It belongs to the family Lamiesi. It's a mint.
Chair, I think Professor Remy means Njoka in his work. I think you need to see Njoka. Thank you.
Thank you very much. I think we have done very well, and thank you for being patient with us. Thank you for understanding when we interrupted you. It is for the same reason that we wanted everyone to present. I think we are ready for lunch, and we want to have, I think, 30 minutes for lunch, and we'll be back here. We finish our last bit of presentations today. We want everyone who came to present. Anyone else? My co-chair, do you have anything that you want to say? I see Madam coming here. Are you coming to tell us lunch is ready?
Sorry, lunch was ready a long time ago. Actually, I want you to go for lunch. Your meal cards are in your bags. So for those who are presenting your meal, cards are in your bags, you're eating at the cafeteria. For the other guests, we are eating at the Innovation Center.
Thank you very much, Daktari. We will meet here in exactly 30 minutes. So for those who are presenting in the afternoon, when you come, you go straight and upload your presentation. Sorry, can you stand so that you are supposed to give your presentation to the gentleman at the corner here, then you'll be prepared for the afternoon presentation. And those who want, you can even do it now.